So let's talk about this geological column. The geological column is the layering of the rocks that you have in the world out there. If you go to a road cut, you can see some of the geological column. If you go to a canyon, you can see more of it. And down here on the left, from the Cambrian, which are the rocks at the bottom, which contain the macrofossils, all the way up, all the way through these various layers until you get up here to the Triassic and the Jurassic. And you all know about the Jurassic because of the movie Jurassic Park, right? So if you have a look to the right, then you will see, wow, the dinosaurs roamed in that time period. And as you go up higher, you come to the tertiary layers, the Cenozoic, and in the top layers, you have the birds and the mammals and man. So you have a sequence of fossils in the rocks as well. So two problems. Number one, you have a sequence of rocks, layers of rocks, where did they come from? And you have a sequence of fossils in the rocks, where did they come from? Science says the rocks are a record of time in the history of all geology. So that's a record of time. So when the Cambrian was present, that was the surface of the earth. Then later, through periods of sedimentology, you got the next layer and the next layer and the next layer. And in the Triassic, that was the surface of the earth. The top layers had not yet been formed. And then the next layer and the next layer and the next layer. So that is what is determined by science. And of course, each one of those layers also contains fossils. So science says the order and the sequence of the fossils represents the evolution over time. That clear to everyone? That's basically the basis for the entire evolutionary theory. And because mutations are normally harmful and mutations have to take place by chance and the probability of getting good ones is pretty remote, there's a lot of time involved in this whole sequence. So generally speaking, we count anything from 600 million years since the Cambrian to the present for all of this to have happened. That's the theory. Now in the first lecture tonight, we're going to look at this side of the column. And we're not going to look at the fossils at all. But hang around for the second presentation, then we'll talk about some of these fossils. So first the rocks. Evolutionary theory is a theory which sort of takes creationism with a pinch of salt, even ridicule. So you'll find things like this in the science magazines of the world. Creation theory, and of course the idea in this New Scientist presentation over here is that we actually did evolve from ape-like creatures, and that eventually once we don the glasses and look intelligent, then we look for a higher origin just to give us some bravado. Or this one also comes from a science magazine, New Scientist. Sorry, but we've just realized that you're an irrational projection of our collective unconscious. So God is marginalized. And then the tables are turned. In this one over here, it says, is science in your life? You know, like a minister would go and say, is the Lord in your life? So scientists come to the minister and say, is science in your life? So basically, there is a sort of measure of truth in it, that there is more than meets the eye in this theory. Let's briefly run into the past. Let's speak about origins. If you look out there and you see all the myriads of stars and all the galaxies, you ask yourself, where did they come from? How did it all start? Science comes up with the Big Bang model. According to this model, at some stage, as I said right here in the beginning, there was an explosion in this totally compressed area, a black hole with the entire substance of the universe compressed into this pinhead. And this exploded in this huge vacuum which we call space. There was no matter, there was nothing. There was just a huge burst of energy and a massive explosion, tremendous heat, and then as it expanded, it cooled, and eventually the first particles started forming. First the subparticles, then the first particles, then you started getting the protons, and once you had a proton, you had hydrogen. And then these hydrogen gas clouds in this vacuum would coalesce upon each other, and eventually, through gravity, coalesce and again form a star. And in that star, you would have nuclear fusion. So all the atoms and elements that we have in the world today had to be formed then in a star. That had to again explode in a supernova. Boom! Putting all this new matter in the form of dust into the atmosphere, into the space. Out of that had to coalesce new stars and planets. And then eventually you could have the matter that it takes to make life on this earth. Well, the Big Bang Theory is not as simple as people would have us believe. And there are major problems with it. We haven't got time to deal with it. I just want to show you an article in the journal Nature, that's the top science journal in the world, which says the Big Bang, not yet dead, but in the decline. It goes on to say there's a crisis in cosmology, and that there are ages of the universe which imply that stars are actually older than the universe should be. So there are major problems with this theory. Well, I'll give you one example. If I have an explosion in a vacuum, do you think it's possible to take the gas that spreads out in the vacuum and make it come together again and form a star? If you pop a balloon, can you gather the gas together again and compress it into a point, yes or no? Have you tried that? Well, you take a bicycle pump and go, what happens? Do you compress it? Can you compress it, or does it push out? It gets to a point where you can't push it any further, right? So the pressure outward is always greater than the attraction inward. And so there's a major problem to get it to coalesce. Secondly, if you have an explosion in a vacuum and it goes out linearly, pow! Why is everything in the universe in clusters, superclusters? Why is everything going round and round and round instead of just shooting out from the center linearly into everything? Millions of problems with this theory. Okay, so let us say, for example, give them the credit, let's say it happened, for argument's sake. And here we are. Now, what we have to show our origins is what we can see in the world out there today. If I go and I touch a rock, if I pick up this rock, I can say, well, how did this rock come into existence? What are the circumstances that led to the rising of this rock? How did the fossils come into existence? Those are questions I can actually go hands-on and study in the environment. Now, the Bible says that this world was destroyed by a worldwide flood. Is that correct? Okay, that's what the Bible says. Science says there was no worldwide flood. Life was never destroyed on this planet in totality. They will admit maybe to a local flood. I have a problem with that. What's the point of building an ark and putting all the animals in the ark if there was just a local flood and the animals were surviving out there anyway? Does that make any sense? Not to me. So there are big differences in these two approaches. Science says that the layers in the geological column point to millions and millions and millions of years of evolutionary process. And that when the bottom layers were the surface of the earth, it was much like it was today. And the next layer, much like it was today. And the next layer, much like it was today. So what we have today is a record of what we had in the past. Whereas the Bible says everything was destroyed and must have evidence of a worldwide deluge. Doesn't that make sense? So what can I prove? Can I go back to the creation itself? No. I can only look at what there is now. And if I look at that, then I can only look at what the rocks have to reveal. So let's just run through the biblical chronology of the flood.